So hello everyone, I'm Henry. I'm the CTO and co-founder at Conduct. Just a little bit about myself. So we started Conduct a couple years ago. Me and my two co-founders, we also all worked at Palantir together, where we worked with a number of large enterprises and came across a lot of the same repeated problems. So I led the engineering team over in Japan, and the other two, one of them led the AI platform in Europe, and the other was in sales in Europe as well. So we're talking about how we at Conduct have built this context layer that we've deployed at a number of large enterprises, companies like DHL or Heidelberg Materials, the world's second biggest concrete manufacturer, and a number of others out there. So yeah, a little bit about us. Our mission is to allow IT teams to run faster. So we'll dive into, before going into what that means, a bit of background. What does enterprise IT actually do at these giant companies? Then what is Conduct? What is a context graph? That was mentioned, of course, in the title as well. And then some details about how we got to where we are today, where we've got this deployed actually in a lot of large enterprises out there. So let's start with what's to do with enterprise IT. So anyone who's worked with enterprise IT has probably experienced that they can be very slow, they're big, very expensive. So if you take a company like Bosch, you probably think they make your dishwasher or your drill or whatever, and yet they have 20,000 full-time employees in their IT department. Like, what the hell are they doing all day? And that's not counting the thousands of consultants they have as well. Allianz, an insurance company, spends $5 billion on their IT. Again, that's a huge amount of money, and despite all of these resources, they take a very long amount of time to do often seemingly small tasks. So one of our customers spends 13 months implementing new pricing rules for their UK deliveries. So that means that they're missing out on revenue for 13 months that they could be realizing with this, and it's taking a really long time to get there. So why is this the case? Why are they so slow? Well, we think of enterprise IT often as like the service help desk. They're managing the network infra and the laptops, but in a large enterprise, they're actually more like software companies. Why? Well, if you're a company like, say, DHL, who are a global leader in delivering parcels and packages, you have established some ways that you're better than your competitors, right? That's how you've got to this position as the world's dominant package company. They have huge operations with 600,000 employees as well. So no off-the-shelf software is going to get you that optimized workflow at that scale. And so all of these companies have encoded their decades of hard-earned competitive advantage in custom processes supported by custom software that they build. What is the tech stack they use? It's not something like Java or that you might expect. They build their software on ERPs. So ERP, enterprise resource planning systems, these are systems, monolithic systems that run all of the large enterprises you see out there. And they do absolutely everything. They're famous for doing accounting and payroll, but they literally, they control machinery in factories. There are modules out there specifically for electricity companies and gas companies. There are hotel modules that you can add on to SAP for running specific things like that. So SAP is the most popular ERP out there. 90% of Fortune 500 companies use SAP as their ERP. There's a couple of others like Oracle and Microsoft Dynamics out there as well. Crucially, you can write custom apps in SAP. So the language you use, the programming language you use to write custom apps in SAP is called ABAP, Advanced Business and Analytics Programming. The front end, you might think, OK, React. No, you write Fiori apps. And there's these things called classic ABAP reports as well. And the database, the modern database they recommend you use is HANA. Now, unless you work in enterprise, these are probably slightly unfamiliar terms. And what you can see is that there is this entire parallel tech ecosystem that exists in the enterprise world, which is not particularly touched by AI in the way that mainstream software engineering has been so far. And the scale is staggering. So at a lot of our customers, they have over 100 instances of SAP running. Each of these might have 10 or 30 million lines of custom code. And there's a lot of complexity. The costs to upgrade from the old ECC version of SAP to what they call S/4HANA, the brand new one, ranges in budgets between $100 million and $1 billion for a large enterprise. Adidas spent $500 million, for example. And this is what the software looks like, by the way. So it's retro, but it does the job. And the counterintuitive thing, perhaps, is IT, because they're running as a software company, they need to do essentially product management, right? They need to know what are the processes that the company runs, and why do they do that, right? If you're optimizing a warehouse and you're writing software for it, you need to know how the warehouse runs. And this means that we can read the code from SAP and all these other systems, but there's a lot of real-world context you need. So here's a real example from one of our customers. We saw some code in some ABAP that said, if the forklift's carrying a large pallet, tell the driver to go right. Seems fair enough, but like, why? It's because the gate on the right in the factory is too small. So it might be the other way around, actually. Yeah. Anyway, you get the idea. So all of this context is not there in the code. And you might think it's in documentation. I promise you it is not written in a single wiki or a single Word document in that company. So what ends up happening is that when companies ask for customizations to these systems, new features, for example, only 15% of the time in these IT departments is spent writing code, and the rest is spent on interviewing the business on what they do. It's spent on defining what the new application should look like, because they've forgotten what their old code base already looks like. A lot of this is also the effect of consultants coming in and out, right? You might hire 1,000 Accenture developers for a project, but then they've left by the end of the project, so that knowledge is also gone. So you spend an inordinate amount of your time and budget doing this sort of analysis work rather than writing code. So the output from an IT department you might expect to be software or code or something tech-related, but actually a lot of people's entire day jobs is drawing things like business process diagrams. This is what's called a BPMN diagram, an industry international standard for representing business processes. Or they might be writing effectively a requirements document. They're called functional specifications in this particular industry. So this particular example is about 17 pages long, and some people's day jobs is doing this day in, day out, and nothing else. So what is conduct? With that background, it sort of becomes a bit clearer. Conduct accelerates managing custom IT systems, and we are the system of work for doing this. So IT teams operate agents that do the same work. They might produce a diagram or a specification document, but they can do it way faster because they have an agent doing that job with them, and the agent has access to the actual SAP and Salesforce and whatever systems, as well as the context. And there's a whole plethora of other IT systems out there that we support as well. And what's most exciting for us is that over time, we capture that context that was lost. Why are forklifts being routed to the right or left? Or in a sales process, why have they decided to do it in a specific way, or did they change their mind halfway through because the business pointed out actually it won't work in this exceptional case? We capture all of that context on why have they designed their systems in that way. So this leads me on to this next point. Context graphs. What is a context graph? So this was a topic that went viral, at least when enterprise AI, sort of x.com circles and LinkedIn a few months ago. And it's published by Foundation Capital. The idea is AI's trillion-dollar opportunity, as they put it, is that AI agents capture not just the decisions. So you might have a Salesforce system that records that a sale was made, but something like Salesforce doesn't capture how was that sale made? Was it difficult? Were there specific terms negotiated? Was there an exception to the process? But knowing that context is vital if you want to run your enterprise agentically. And what we're very excited about is that we believe that sitting in enterprise IT, at least in large companies, is where you capture that information. And we're right in the path where they do that work and capture it. So how do we do that? Well, let's go back to early 2025 or late 2024. We tried building a literal graph database. We took the code, we mapped it, the relationships between different classes, which bits of code read which database tables, and we linked it also to any documents they had, any wikis, etc. It didn't really work great. It was very slow to construct, partly from the sheer volume and the amount we had to parse. There was a staleness problem. These systems are live, they change all the time. So what ended up happening is that users would be querying something that's out of date. How do you insert a change? Like if one of the nodes represent a class in the code and someone deletes that, what relationships do you delete? How big is the blast radius? It's not entirely obvious actually when you get into the details how to manage it. Actually doing queries through the graph, I mean graphs, if you have one node and you look at the neighbors and its neighbors, it grows exponentially, right? So it's very hard to write good queries. And permissioning also was another thing, very important for enterprises. If a user can look at one piece of code, but not a document related to it, graph databases, at least at the time, didn't really have great ways of expressing that sort of permission. So we moved away from that. Another idea might be, well, what about if we just go for an agent reading a file system, very popular now with things like Claude Code. We didn't love this either. How do you represent a lot of the relationships that we want to keep track of in a very sort of deterministic and 100% reliable manner, such as someone produced this diagram, it has been approved by their manager, and then someone's written a specification derived from that diagram. You could do it in agent MD files, but agents might also clobber that, etc. Also, this is specific to us, but SAP's code is actually stored in database tables, not in files. Synchronization is quite awkward. How do you do collaborative work? Like, if you have 200 consultants and we want to be a collaborative platform, it's very hard to get them to work on the same copy of the file system. How do you make sure they don't clobber each other's work? Permissioning was another problem. Like, enterprises have very, very specific permissions. They'll have like 50 groups, and each of them has very granular permissions, what they're allowed to do and not allowed to do. And again, the scale. Like, when you're dealing with this many lines of code, this many billions of lines of documents, Claude Code, it has its limits because the tools that you've given it are not necessarily designed for this. There's also a bunch of enterprise challenges, right? So I'm not touching on every enterprise challenge, but the ones that are relevant to this topic today, I mean, the key thing is that CIOs must always feel in control. Otherwise, they're never going to buy your software. And that means things like individuals have to be allowed to only see the data they're allowed to see. So if you have a factory floor worker, they certainly shouldn't be able to see payroll data. They must also only be allowed to do certain things. So they must only be able to, a factory floor worker can't change someone's pay, for example. We need to ensure repeatability, that sort of approval gateway where someone produces a thing and their manager has to approve it before moving on to the next thing, that must also be enforceable. The other thing is sprawl. Like, we have a lot of systems. If you have 100+ ERP systems, let alone everything else, managing all the complexity of the thousands of LLM tools that you might get if you use MCP servers, or the different permissions and how they interact with each other, it does become quite complex. And this is where we realize a lot of these problems are not actually new. How were they solved in the past? Because in the end, there were SaaS platforms for enterprises which solved these things, right? Well, first of all, a lot of the problems around governance and permissioning, et cetera, were just handled in root handlers in HTTP APIs. So that's kind of analogous to tools. We can kind of use that. But then the other thing is data modeling. Rather than graph database and file systems, in the past, you've always exposed a REST API or something similar. So you can just represent things simply as there's verbs that you can get or put, et cetera, or delete things. And then you have resources with IDs, which is effectively the URIs. And there's also this pattern which not every system follows, but we took some inspiration from the sort of principle of HATOS, I think it's pronounced, where when you return values from a REST API, you return also links to its relationship so that you can actually discover other related entities without having to know the whole API schema up front. Right, so here's an example of a HATOS-compliant REST response. You can see the links here. Even if you don't know, this is returning a book, but even if you don't know that there's an author entity or a reviews entity, you can kind of discover these, kind of analogous to relationships in a graph. So the way we modeled a lot of the things where we were having these challenges was viewing everything as a resource with an identifier, and just having more general tools like get or search, where you could then search for a particular entity, and it would then get returned as a JSON, similar to just as if the agent's using an API. And then the business logic could be encoded in a very similar pattern to just having a URL handler. And that's where you could put permissions, specialized logic, or if you have to fetch from other systems in real time as well. So what does that look like in practice? Well, let's step through an example. So the LLM might search for the keyword invoice in the code base. And we might say, OK, we want to search for code, documents, and BPMN diagrams. We can come back with a list of search results with identifications. And crucially, we can see here also relationships like, OK, this diagram is derived from a different diagram. And here is the context thread, right? Here's the conversation that led to having the conversation the user had to edit that diagram. And so if an LLM wants to look up any of those details to complete its task, it can just get that diagram. It could also get the thread if it chooses to. And the tool there's another tool for updating, so it could also just update it once it's chosen how it wants to edit that. So what were the benefits we saw with this? Well, first of all, like I said, permissioning, access, sync logic, et cetera, it has a very clear home, and it helped organize a lot of things rather than just having thousands of tools everywhere with their own patterns. The graph relationships become still very easy to find through the sort of the JSON keys which map to those. But we can also control them, right? It's not just agents creating them and deleting them. If we want to track the provenance of this diagram led to this specification document, we can enforce that in the business logic, that's always enforced. It's also just new integrations fit easily. Like if you expose a new type of resource, like maybe we add support for a new type of, I don't know, we already support them, but let's say we support some wiki. And there's now a clear way of identifying this page, an individual page. So now we can fit it into the permissioning model of saying a user has read, write, whatever access to that page in one unified model across all of the different systems rather than having to have different setups for each of them. One other nice side effect of this is that we can also easily get parity between the tools that LLMs use and the HTTP APIs we expose in our services. And that means that there's a lot more parity between what humans and agents are able to do. We managed to reduce 100+ tools down to under 10 with this. So as we expand the number of systems we support, this can help keep a lid on the number of tools as well. Actually, we thought that this was going to get out of hand quickly because we were at over 100 and we weren't supporting that many systems just yet. So this was quite a big win. And crucially, we also don't have to use this, right? Like, of course, there's a lot of overhead having to implement this. So if you just have a very simple service where maybe permissioning is much more simple or you're less worried about having to do edits and updates, you can still just plug in an MCP server and it just works side by side with that as well. So having set up this system, what's next? Well, I think one thing we're keen to explore, which we haven't yet, is programmatic tool calls. Like, can we have agents use these effectively like API calls and compose them to write their own queries? Could we actually extend this concept to also how the LLM documents its own findings and knowledge, similar to sort of the things that Kapati writes about maintaining your own wiki? And this is a very sort of broad point, but one of the things that we also observe is that with these primitives around permissioning and really constraining how workflows work, you end up with like very small workflows that are kind of limited in what they can do. And of course, the dream with AI is that we want to have these long-running long-running agents that can complete tasks end to end. Now, enterprises are not very comfortable with that nowadays, but by giving them a starting point with these smaller agents that do one-off tasks that they understand, they already trust a lot of the work that we do, because they understand it, right? And the functional analyst can use the functional analyst workflow to accelerate their work. They're comfortable with that. But they organically notice over time that actually these different workflows could be stitched together, and then you might as well just have one big one. And we're slowly seeing a world where they're warming up to this idea, and we're able to take them on this sort of change management journey of going to this world of long horizon agents. And we think having these building blocks helps a lot because we're able to really dial up or down how constrained we make the agents, how broad we make the permissions, or do we really make them constrained for customers who are maybe a bit less convinced? So that's it from me. Thank you very much, everyone, for listening. We are hiring and are offering a $20,000 referral bonus for anyone who refers a successful hire as well. And this is to be announced, so I'm just sharing it here. We'll share more details in a few weeks. We have also just closed a $50 million Series A, so happy to talk about that if anyone is interested as well. Do visit our careers page. I've also put these logos down here just to highlight we are working with the big giants in this industry. Despite being such a small team, we have a board-level endorsed relationship with SAP, an official partnership with them, as well as with big system integrators like NTT Data, BCG, and others who are yet to be announced. So thank you very much, everyone.